The following workshop will be recorded and shared, and we will not be recording anyone's video except the presenter's screens. The sound, such as any questions you ask or answer, will be a part of the recording. And some land acknowledgement, nwPlus is based on the UBC Point Grey, Vancouver campus, which sits on the traditional ancestral unceded territory of the Coast Salish Musqueam First Nation people. Yeah. All right, now an introduction to our workshop. So here's the timeline. This is how the structure of this workshop will be like. It'll take around an hour and 30 minutes for us to cover everything, and we'll be going over 2 simple technical questions this session. The first question, I will act as an interviewer, and our TA Maggie will act as an interviewee, so you can kind of see how an interview might be conducted. And we will then introduce the second question. And if you think it's too easy, then you can feel free to leave. But if not, join us and try solving it on your own while we prompt you through it. So that's basically the gist of the content we'll be covering today. So before I continue further, I'll introduce myself and the team first. I'm Christy, and I'll be hosting the workshop. We also have our TA Shooting, Rebecca, Shirley, Maggie, Ben, Anne, and Allison, and they're all going to be helping to answer questions as well as guide you through the workshop in the latter portion. So, regards to asking questions, so if you haven't joined the Slack workspace already, please do. And we also have our channel called the Technical Interview Workshop, and join that. If you have any questions, just message question in all caps with your question after that, and TAs will reply to all of your questions within your post thread. So try to reply to those replies within the thread as well. And if you want to ask a question on Zoom, definitely feel free to do that. Just put up your hand and then unmute yourself once we call on you. Yeah. So without further ado, what is a technical interview? So interviews are used to gauge what you know. The company wants to understand how you think and solve problems and assess how they can work with you. It's very important to know that interviewers care about your thought process more than getting to a working solution without actually understanding how the solution works. So you can expect to have a mix of behavioral and technical questions at interviews. And the questions will most likely test the skills you have put on your resume. So make sure you know everything you have there. And the interview structure. So you most likely apply for job positions online through referrals or at hiring fairs. Once a company has your information and feels you may be a good fit, they may choose to send you a coding challenge or a coding assessment. The coding challenge is usually 2 to 5 technical questions that you need to finish within a specific time limit. And the company will then take those results from the coding challenge to decide if they want to move you forwards with an interview. If they choose to proceed with an interview, you will get either a phone or a video interview, and it'll start off with the interviewer introducing themselves. Then you'll introduce yourself as well. And you will then talk about your projects, accomplishments, involvements, etc. Just make sure everything you wrote on your resume, you have a good understanding about, and you can expand on those topics. After that, you will jump into one of the 2 technical questions. So some do's and don'ts during the interview. What to do. Although it may feel awkward, it is extremely important to think out loud when trying to do a technical problem. The interviewer is trying to understand your thought process, so you have to guide them through it. So you could try something like using body language, where virtual interviews might seem awkward since you're staring into a camera, but body language might help to ease that tension. And you should always go into an interview having prepared questions for the interviewer to show them that you care about that interview and just to answer any thoughts you might have. While you're preparing for those questions, you could also do a little research on the company background so you can better answer questions like, why do you want to work for this company? And what not to do in an interview. Sometimes when I'm nervous during interviews, I forget to talk about what I specifically did when asked about group projects. So as much as it is important to hear about what the overall project is, it is more important to know what you contributed to it and if you learned something from it. It's also important to be able to demonstrate a thorough understanding of whatever you claim to have learned from that project. So if you're talking about a skill, make sure you actually know it. Something else that happens often during the technical portion of interviews is forgetting to ask for help. So the interviewers are there and they want to help you if you're genuinely lost or stuck. Ask them if they think you're on the right track or if they might have any tips for you to get back on track again. Again, as mentioned previously, make sure you're thinking out loud or at least commenting your code so the interviewer isn't lost with whatever you're trying to do. So even if your solution doesn't work, if the interviewer realizes you have a solid grasp of the concept from your comments, you actually have a much you have a much higher chance than not saying anything at all. So some tips and tricks. Since there's COVID, all interviews are virtual now. So it's nice to set up your interview environment early and test things out so you know everything is working. And although during video calls, it's very tempting to look just at the face on the screen, you should try to make eye contact with your camera instead so your interviewer can see that eye contact. And for those who have unstable internet, mention it to the interviewer beforehand and they'll be super understanding about it, even if it randomly cuts out. So if you're wondering what an in-person interview would be like because you haven't been to one, the technical portion is usually at, at an office and you code on a whiteboard. So studying tips for technical interviews. I always try to review the data structures and algorithms that I'm not confident in by writing out their implementation. That's not necessarily every single data structure and algorithm, just the ones that you feel like you aren't super familiar with. So just review those. And I always try to draw out examples or diagrams and walk through those pictures with my solution before actually writing any code. And you can try talking out loud when practicing your solutions. Use paper, whiteboard, Google Docs, anything without a compiler to write your code. And you can run it with a compiler afterwards to check it. So that will work out. And then interview prep isn't fun, so just find a friend and suffer through it together by practicing with each other. And here are some possible styles of questions you may come across during your interview. You may get debugging, drawing UML class diagrams, drawing software architectural diagrams, just writing pseudocode, or the classic solving technical questions, though some of them, like if you're doing a coding challenge, it's just focused on completeness. Once you pass all the tests, then it's fine. But if you are doing a technical interview in person or like over the phone on video, it might be more focused on the space and time complexities. And for front-end position interviews, it's possible that the interviewer will ask you to create a tic-tac-toe game or maybe center an image using HTML or CSS. All right, excuse me. So the technical interview breakdown, what should you expect? And these are just some steps you can use to approach a technical interview question. So I'm sure many people would have heard of the STAR method. It's very common. So S for situation, T for task, A for action, and R for result. So situation, you want to always listen when you're given a technical problem. Listen to what the interviewer is saying during the problem description and try to understand what you're trying to solve and ask any questions if you're confused about anything. Secondly, we want to think of a bunch of examples, the base case, the average case, and the edge cases. So once you have an idea for some sort of solution, write out simple pseudocode for your initial working solution. And pseudocode is basically just a plain language description of the code. No need for any of the proper syntax. So if you're writing stuff in like Java, you normally have all the brackets and the colons and the semicolons. But with pseudocode, all you do is say, if this, then that. Very simple English. And if you can't come up with how to solve the problem, go to your base case and try walking through that. Now, on to the action. You want to write the actual code now by turning your pseudocode into actual code. So with that, you want to pick a language that you feel most comfortable in. Choose appropriate variable names and comment what you want your code to do. Sometimes with your comment, your interviewer might be able to help you catch bugs. They will notice that you intended to do something else through your comments, but your code is actually different from what your comment says it should do. And bugs are completely okay to have. Just try to catch them early by stepping through your code with the examples. And if you want to use libraries or modules, ask the interviewer first, because sometimes the question that they're asking is intended to test you on how you would implement a specific thing that a module or library could use. And to add on to having clean code, if the solution is complicated, you might want to consider using helper functions. So there's something called the single responsibility principle where you want each function to just do one thing. Keep it simple, stupid. So the final step is to test your code and ask for feedback. Run through the examples you wrote out and try to fix any bugs or mistakes. Check in with your interviewer while you're running through your examples that you're on the right track and use their feedback to improve your code. Now look at your solution and figure out the space and time complexity. Is there a way to improve either of those? If so, and you have time, you can try refactoring your code such that it becomes a better solution. And if you don't have much time left, then let your interviewer know that you know of a more time or space efficient solution, how you should implement it, the pros and cons of using that solution versus your current solution. And that would actually be, I'd believe, a 10 out of 10 interview, but don't worry because you really only need an 8 out of 10 interview to pass most of the time. So just keep practicing as much as you can and aim for that 10 out of 10. And in case you don't know what time and space complexity is, this is just a very brief description. These are quite difficult topics, so we won't dive into too much detail. And you'll probably be taking a course later on that will cover this in very, very good descriptions. So a super basic definition of what time complexity is would be the worst case time it takes for code to run from start to finish. So let's say you have a list of 10 items and you want to count through the list. In your code, you decide to use something like a for loop to iterate through each of the 10 items. Therefore, it would take you 10 items amount of time from execution to finish of the code. But if you had 100 items, let's say, then it would take you 100 items amount of time to go through that for loop. So therefore, let's say you had n items, then it would take you n items amount of time. So iterating through a list one at a time would take O of n time complexity. I know that's like really hard to grasp if you haven't heard this before, but just stick through and we'll kind of give some more examples later. And this is something called big O notation that we use to denote time complexity and space complexity. So following up with the example of counting items in a list, imagine you have a box and the box is your list. So how much space does that box need to hold 10 items? It needs 10 items in amount of space. So if you want to put n items into the box, then it would take n items amount of space. Therefore, the space complexity is also O of n. And without further ado, we're going to jump into our first sample problem. And Maggie, our TA, will be helping us to go through that as the interviewer, and I'll be the interviewee. But before that, I'll just talk about the language we're going to be using for this. So we're going to do our first sample problem in Java and our second sample problem in Python. I'll just talk about why we want to use Java for technical interviews. So it's a powerful general purpose programming language, and it is almost always a language that you can use during your technical interviews. I don't think there's ever been a technical interview where I've gone to and they said you can't use Java, unless like if it's a front end position or you're doing very specific tests. So it's just nice because we also learn it in 210. All right, now the actual question. So we're going to be solving two-sum. Given an array of integers, return the indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution and you may not use the same element twice. So here we have an example of an array of integers. We have 2, 7, 11, 15, and we want two numbers that add up to 9. So our solution, you notice, is returning indices. So we have nums 0, nums 1. Nums 0 is the number at index 0 in the array, which is 2. 2 plus 7, 7, which is the index 1, equals 9. So therefore we return 0, 1. But Maggie will walk through this in more detail. All right.
All right, so from the description of the question, I've gathered that the input is an array of integers and the other input would be an integer, which would be the target number. There are only two numbers in that array that add up to said target. And the output is an integer array of the indices of those two numbers that add up to the target. Each input only has one solution, and I cannot use the same element to add up to the target number. Is my understanding of the problem correct so far?
Yes, the inputs and outputs are correct.
All right, so off the top of my head, I have a couple questions about that. What happens if there is no answer?
So if there's no answer at all, you can throw an exception saying there is no two-sum answer.
Okay, and can there be negative numbers in that input array?
Yes, so you can assume that this integer array could have any integers, which would include negative numbers. And right now, we'll just take a quick pause. If there's any questions about this two-sum question, feel free to put them into the Slack, or you can put your hand up and we'll call on you and unmute yourself and ask questions. But if not, we'll keep going.
All right, so this is the point where I should write some examples and go through them, see what they should output. So if we start with just a short array of 1 and 2, and you have to add up to a target of 3, then obviously 1 plus 2 equals 3. So we have 1 at index 0 and 2 at index 1 right here. So it should return 0 and 1, which is, yep. So, and then if you have an array of 2, 7, 11, and 15, and they have to add up to a target number of 9, then once again, we have 0 and 1 under, the number 2 has index 0 and 7 has index 1. So it should still return 0 and 1. Now for the third example, we have 2, 2, 3, 100, and 39. We have to add up to 41. And obviously it's 2 and 39, but I see a lot of question here. Christy, is it correct to assume that I should return the index of the first appearance of 2?
Yes, you should return the first appearance. So for the third example, it would be the index 0.
All right, in that case, we will be returning this one, which is at index 0, and 39, which is at index 4. Now, we need to try an array with a negative number in it. So we got 11, -1, and 10. And let's say it adds up to 9. And then you can see -1 is at index 1, and 10 is at index 2. That was a really bad 2. Anyway, yeah, so it should return 1 and 2. And then to test the no solution case, we have an array of 1, 2, and 3. I'm bad at math, but I'm fairly sure all 3 of them can't even add up to 100, so it should return no two-sum solution.
Yep.
And because I am a good candidate, I always test my empty cases, my empty inputs. But yeah, Christy, what should it do if the input array is empty?
So for this particular question, we can just assume that it's impossible to have an empty array and just leave it out. But as a note, other interviewers may ask you to return no two-sum solution or another answer if you're given an empty array.
All right, sorry. So the first solution that I can think of is, of course, you take every single pair of numbers in the array and you add them together, see if they match the target number. So if we do something like that, then we would need a nested for loop. And in case you don't know what I'm talking about, let's just say you have an array of 1, 2, 3, and 4. Then we would assign the variable x to index 0, in which case it would be 1. And then you got j is equal to 2. And then you're like, okay, do x and j add up to equal to target? If that is false, then you would basically move j to the next element. If that's also false, move j to 4. And then if that still is false, then you would reassign x to 2, and then j will be pointing at 3, and then so on. So basically, you literally try every single combination of 2 numbers. And the time complexity for something like this would be big O of n squared, just because you have to go through this entire array of numbers, like n items in this array, n times. So it's not very efficient, but space complexity is constant. So because we are not creating any new arrays or anything. All right. I think I can improve on that solution. So instead of doing a nested for loop, I can use a hash map to keep track of the numbers and their indices. Because hash maps have a lookup time of big O of 1, so it's constant time, whereas looking through an array for a specific number will take big O of n time. So I think using a hash map will probably be better. So first step I want to do is to basically copy every single value from the array into a hash map, which is what this for loop will be doing. And then I will make a second for loop, which will basically check. It will go through every single number in the array and see if there is a number in the hash map that will add up to the target number. And just for simplicity's, the ease of communication, I'll just define the complement as a thing, another number that you add to a given number to make the target. So if you, as you can see at the bottom, like if you have a number 2 and you need to add up to 3, then the complement to 2 will be 1. And then if you find the complement of that element, then you would return basically the index of that number plus the index of the complement, which is what this line means. And the time complexity of that would be big O of n, which is a lot better than big O of n squared. But space complexity would be big O of n because we are making an entirely new hash map and putting n elements into it.
All right, yeah, this solution looks like you're on the right track, so you can start implementing it. And if there's any questions, again, plug them into the Slack workspace.
So the first thing that my function should do is create a new hash map. So it would be empty. That's what this line does. Right, and then this for loop right here, it basically takes every element from the array and puts it into the map. So by the end of this step, it should have, the map should have every element of the array in it. Right, and then I will add a second for loop, this one right here. And this line here basically will calculate the complement for every single number in the array. And then it'll just store it in the variable called complement. And then this if case right here will just look in the hash map to see if that key, so if the complement exists as a key. And if it does find a key that matches the complement, then it will go to this line where it will return a new integer array, where it will have the index of your first number, which is I, and the index of the number that you found, the complement that you found in the map, which is what that number is. So that would be the value of that key. And let's do that. So now let me step through this code with the first example we had before. So in the first for loop, we have a hash map with a key and a value, and then we take the first element of the array, 1. We put that in as a key, and then the value would be 0 because it is at index 0. And then we put a 2 in as a key with 1 as its value. So that's done. And then in the second for loop, we're basically, it's going to do something like I equals 0. And then it'll calculate the complement, which should be 2 because 3 minus 1 is equal to 2. And then it'll find the 2 right here. So it'll return I, which is currently 0. So I can't draw it, of course. Okay, 0, and then it'll return the value of 2, which is 1. So right there, that exactly matches what we expect. So that's perfect. So it seems like the solution works with this example. Am I on the right track?
Yep. So this looks like you're on the right track. Maybe try a few more test cases and you'll discover some other things. So again, if you have any questions, feel free to put it into Slack workspace. And if we're going too fast or too slow, make sure to press the too fast or too slow button on Zoom and we'll try to adjust for that.
Okay. Wait, can you go to the next slide? Okay, I just remembered that there was that condition where I cannot add the same element twice to make the target. And I didn't exactly have anything to ensure that it doesn't happen. So that's basically why I added this little condition in the last if statement. It's just saying if the index of the complement is the same as the index of the number that we were currently iterating on, then of course that means they're the same number. So that can't work. So it'll just keep going through the for loop. It'll just ignore that. All right, so now we're just going to go through another test case. We got the one where you have to add 1, 2, or 3 and make 100. And obviously that will not have a solution. But so it should return no to some solution, but it looks like I forgot to implement that as well. So it's just not going to return anything. So I am going to add a new line right here. Where basically, if it goes through the entire for loop and it still hasn't returned a solution on this line, then it will go down to this line and throw the new exception. So now it should work for this test case. Yeah, so as a result, as you guys can see, there are 2 for loops, which means the program goes through the list twice. So yeah, it's big O of n. And the space complexity is also big O of n, just because we made another hash map.
All right, so this looks like a good functioning code or solution, but we're going to try to think of how we can optimize this any further. And for the sake of time for this workshop, we're not going to go through any more examples for this solution, but definitely during your actual interview, if you have a working solution, you should run through like 3 to 5 examples just to make sure you've covered all the edge cases and it's not going to break at any one of those. But for time's sake, we'll be moving on. So again, questions in Slack.
All right, so now I'm going to start thinking if I can keep optimizing this code, because interviewers do like cleaner code. So right now we currently traverse the array of integers twice, but I can think of a way we can do it only once. Because previously we traversed it once to put everything into the hash map, and then once again to check every single number and see if it has a complement. But what if we just put the elements in the hash map as we went? So if we have, once again, the int array of 1, 2, 3, 4, it will look something like, you look at the first element, which is 1, and you're like, does this complement exist in the map? And obviously it's empty. So you would put the 1 in there, and then you would go to 2, and then you will look in the hash map to see if that has a complement. And if that doesn't, then you would put 2 in the hash map, and so on. So instead of putting everything in the hash map at once, you can just do it at every iteration of the for loop. So we would only need 1 for loop for that. Yeah, next slide, please.
Yeah.
Okay. So if time allows, you can also implement it in actual code. So instead of making an entirely new solution, you want to just build off of what your previous solution is. So in this one, basically the only change I made is taking out the first for loop that used to be like right here. Sorry, that was a forward arrow. Yeah. Next slide, please. Yeah. And then the second change I made was that I got rid of the check for whether it's the same element twice in here, just because if you think about it, each element is going to be either in the hash map or in the array, but not both. So basically, there's no chance that you're going to be looking at the same element twice. So we don't really need that. So that's even better, makes it look cleaner. And then I add another line where we basically, if the map doesn't contain the complement of the number that we were looking at, then you put that number, aka nums I, into the map. So yeah, that's a really important step, just because I have to remember to actually populate the map instead of just having an empty map the entire time.
Yeah, so this looks like a final solution, and what you can do is go through time and space complexity then.
Okay, so we got rid of one of the for loops, but the time complexity is still big O of n. And space complexity is still the exact same because we are still building a hash map with potentially n elements in it.
All right, yeah, this looks like a much cleaner version of the code though, but now I'd like you to step through some more examples to check if this works.
Okay. All right, so for this array, let's see, I'm just going to initialize the hash map and then just keep track of I and C for complement. So when I is equal to 0, we are looking at this number, target minus num0, that's -2. That doesn't exist in the map. It's going to put 11 and 0 into the hash map. And then when I is equal to 1, target is 10, that's not math, which still doesn't exist in the hash map, so we put that in here as well. And then when I is equal to 2, looks like complement would be -1, and well, let you look at that. -1 does exist in the hash map, so it's going to return I as the first element of the new integer array, which is 2, and it's going to return the value of -1, which is 1. Which raises a question. It's not the exact same as the 1, 2 that we expected. Christy, does it matter what order the numbers are in the output array?
No, so as long as you have the indices, it doesn't matter.
All right, perfect. So by that definition, we have succeeded for this example. All right, I'm gonna go to this one. Once again, set it up like this. And you go to I equals 0. That does not exist, so we put that in here. And we do the same thing for the other 2. All right. And when I is equal to 2, we'll be looking at a complement of 38, which still doesn't exist. So we put that in here. When I is equal to 3, complement is -59. So we've got to put 100 in here as well. And for the last element, 41 minus 39, that's 2. So we have 2 2s here. And from what I know, map.get grabs the first element in the map that fits what you're looking for. So we put 2 in there. It's going to grab the first 2, which would be this one. And if you remember from the requirements we had before, it will grab the first 2 that appears in the array. So that works perfectly. So it is going to print I, which is currently 4, and 0, which is basically the same thing as 0, 4. So it works for this case as well.
Perfect. So that looks like it's a total working solution. So this is what a candidate would get for like a really good interview. They finish the question off and they run through the examples. And usually the interviewer might be like, oh, are there any other ways to optimize this? If you don't think there is, then just straight up say like, I can't think of any, and they won't question you about it more unless there is like something very obvious, in which case they'll give you some more hints and you can go on and continue working through optimized code if there's time. But like I mentioned previously, if there's a better solution, but let's say it's very hard to implement, then maybe you should discuss with your interviewer, oh, would you rather me implement this harder solution that I know of, or would it be better for me to just complete a working solution for you? So those are some things you should mention with your interviewer. And yeah, questions again in the Slack. So now we're going to go look at some resources that everyone can use for learning how to prep for their interview. So personally, like the team would recommend Cracking the Coding Interview, HackerRank, LeetCode, Interview Cake, and I'll actually also put in Code Signal, because a lot of companies, they like to use Code Signal to test your coding challenges. So questions to get started. So these slides will be posted and public for everyone to access. And here are some links for like nice sites, which kind of step you through like how to get started with prepping. So the first link that's included is really good for cramming right before your interview. And by cramming, I mean like 1 day before or like 3 days before, but definitely not recommended to do that. It's just, it happens. So if you need to cram, then that's a great link to get you started. And then there's also a curated list of LeetCode questions that a lot of other technical interviewees have experienced at big companies or maybe small companies, just questions that appear a lot. So those are nice to get started as well. And some data structures or algorithms that you should feel familiar with, or at least know of and understand how they work. With data structures, you should definitely know arrays, and then linked lists, hash maps, trees, graphs, those are important. And algorithms, these might not be as familiar to everyone. So maybe it'd be nice to like jot these down, or you can refer to these slides later on. There's the sliding window, dynamic programming, search, recursion, greedy, and two pointers. So these are just some very basic ones that I thought of off the top of my head, but I'm sure there's a lot more. It's just, I think most internships, like first year, second year internships, will use just arrays and maybe linked lists. Not actually, most of the time they don't have linked lists. So it's arrays, linked, maybe linked lists, and trees. And then upper years, I guess like you'd have more hash maps, graphs, matrices, that sort of thing. And then algorithms, to be honest, if you're first or second year looking for a sophomore internship, I don't think you need to worry about algorithms too much, because most of the time it's just implementing what you think works. Like you have an idea, then you implement it, rather than like trying to use a specific algorithm. But obviously when you move up and like go into senior or junior, then you'll have to know some algorithms. All right, so to conclude, before we actually jump onto the optional question, so what is some interview mentality you should be having? It's perfectly normal for you to freak out before, during, and after interviews. I literally freak out every day because of interviews, and the first few are especially hard. So we definitely recommend working on these questions with your friends and practicing with each other just for some moral support, and to get that feel of actually interacting with another person. Like all the resources previously, you do them yourself, but it's really nice to have that in-person element where you're talking to someone and explaining things out loud, just so you kind of are comfortable with doing that during your interview. And remember that there's still behavioral questions that are part of the interview process. So technical questions aren't absolutely everything. You should be prepared to like answer questions about your resume, extracurriculars, what your passions or interests are. If you specifically like something about the company, make sure to cover those questions before you interview so that you're prepared for them. And many companies actually emphasize that it's more important for a candidate to elaborate their thought process and show how they can debug, rather than just getting a correct solution right away. So don't feel bad if you don't get a right answer, because the thought process definitely counts. And some key takeaways. So definitely treat your interview like an exam. You have to study for it. That's why there's LeetCode and a bunch of people you can reach out to practice with. And I personally find using the STAR method during my interview helps to keep me on track. and paste up. Before I discovered it, I was just like all over the place. But now that I'm using it, I feel like even though I might not ace all of my interviews, at least I know like, oh, after I compare the inputs and outputs, I should move on to writing out test cases. Then I should move on to the pseudocode. And if there's not time for pseudocode, then I should just start coding right away and remember to step through all the examples. And when practicing and even during the interview itself, it might be beneficial to use whiteboards or paper, or if you're doing it online, maybe just draw in a notebook the solution, really visualize it with diagrams or drawings. And again, bring thoughtful questions ready to ask your interviewers so it shows that you care about the position that you're applying for. And that's it for the first portion of our technical interview workshop. So following that, we'll have our sample problem number 2. This one is a bit more hands-on. So what's going to happen is we'll have TAs split everyone out into breakout rooms, and we're going to try to go solve this sample problem number 2 on LeetCode itself. But definitely if you've heard of Fizz-Buzz and maybe done it before, you can feel free to check out from our workshop right now. But if you haven't, then stick with us and we'll run through this problem. So actually, we're also going to have a 10-minute break right now before we run through the problem, but I'll just leave this screen up so you can see if you've done this before, if this is something you want to continue with. So right now it's 6:13. We're just going to break till 6:23 then and come back. And if you have any questions that you want to ask like any of the team, you can unmute yourself and ask us. I think I saw some like questions in the Slack channel about different things. Yeah. So,
yeah, and even if you aren't asking any questions, our Slack channel is very active right now. There's a lot of advice and good questions, so make sure to check it out.
So we'll come back at 6:23, or you can just pop out now. Thanks. Great. Thanks for sticking through, everyone. So now we just finished our break. We're going to go back to our Fizz-Buzz problem. So I'm just going to talk about why we're choosing to walk through this with Python. So Python's readability makes it a great choice for beginners to coding. So what readability means is just like when you read some Python code, even if you have zero coding experience, it's very likely you already understand what 80% of it means. The syntax is very, very similar to writing pseudocode, and there are many libraries or modules that come in handy when doing the technical interview questions, which can be utilized in Python. And that's why we're going to try this next question with this language. And one other thing that I really like about it is a lot of other languages, you might have to write maybe like 20 lines of code to finish or to get to a solution. But with Python, it might take like less than 5 lines of code, or maybe even like 1 line of code, which is really cool. So yeah, personal recommendation of using Python for technical interviews. And now we're going to go into this Fizz-Buzz question. I'm going to introduce the problem first, and then we'll step through some pseudocode, like go through the situation and task part of our STAR method, and then we'll go into breakout rooms for the action and the result part. All right, so Fizz-Buzz, write a program that outputs the string representation of numbers from 1 to n. But for multiples of 3, it should output fizz instead of the number, and for multiples of 5, output buzz. So for numbers which are multiples of both 3 and 5, you want to output Fizz-Buzz. So pretty straightforward. As you see here, it's like 1, 2, 3 turns into fizz because it's divisible by 3. 5 turns into buzz because divisible by 5. And a 15 will turn into a Fizz-Buzz because it's divisible by both 3 and 5. So again, sticking to our STAR method, we're going to start off with situation. So before I put on the answers there, like think about what the input would be for this. So, all right, I'm going to put it on. The input is going to be a single integer n, and n actually represents the total amount of numbers we have in our final output array. And how about our output? What will our output be? So we think about that again. We'll have a string array where numbers divisible by 3 return fizz, and numbers divisible by 5 return buzz, and numbers divisible by 3 and 5 return Fizz-Buzz. So one question that I could be asking the interviewer if I was an interviewee would be, are the numbers always in ascending order with no repeat? Because let's say you had like 1, 1, 2, 3, 4, 5, 6, then that might mess up your algorithm, or it might not, depending. But this is a good question you could ask. And for our purpose, for this particular question, I'll say like, yes, so all the numbers are just in ascending order and there's no repeat. Right, so now moving on to our tests. So we have to come up with some examples. So let's say we take the original example that they're given. I hope everyone understands this one where like 15 is divisible by 3 and 5, so Fizz-Buzz. And then, yeah, everything else is quite straightforward. So I'm going to come up with another example. So given a num3 by itself, we return 1, 2, Fizz. There's only Fizz in it. And given a num1, we just return 1. And given num0, so this is, we're just going to regard this case as impossible. You'll never be able to get an empty array to begin with, like you'll never just have 0 numbers. So that's a nice edge case to confirm with your interviewer when you're actually doing your interview. All right, so to think about some pseudocode, if anyone has like any suggestions, maybe you could like raise your hand and unmute and talk. If not, then I'll just continue with it, but I'll give it 5 seconds in case someone wants to raise their hand and suggest a solution. All right, I'll just go through it then. So with our pseudocode, we're first going to initialize an empty list. That's what our answer list is going to be. So within that, we're going to make a for loop so that it starts with the range of the first number and then end at the last number of that n we were given. Our input is the n, so it's going to go through each element until n numbers. And we're going to have to check if that number, that I, is divisible by both 3 and 5. If it is, then we'll append Fizz-Buzz into our answer array. If it's divisible by 3, then we just append Fizz. If it's divisible by 5, we just append Buzz. But then if it's divisible by none of those, then we'll just append the number itself, which is I. And after checking all of those conditions, we just return the answer list itself. So because we have to go through n numbers in this for loop, that's why our time complexity would have a worst case of big O of n. And space complexity wise, we would, oh, sorry, this should say O of n because we're initializing an empty list and we have to put in n numbers in it. My bad. I will change these slides later. But yeah, so this is the pseudocode that we're going to be using to generate the answer. And now we're going to break out into the breakout rooms and try to code this on LeetCode together. Hopefully everyone got to learn something during that breakout room session. So there's probably multiple different solutions to solve this problem. And I won't go through all of them, but one of the simplest solutions is we first follow the pseudocode that we came up with. So we initialize the answer list first as an empty list. So this is just going to be what our output array is going to come out as. And we're going to go through each number within that n, because n, let's say it's 15, then we have to go from 1 to 15. So we're going to go from range 1 to 15. And because Python does have open brackets, so like when you're going from ranges, it's not closed bracket. So n+1 actually stops at n here. So what we're going to do is we're going to create these variables or these factors, these functions, which we call divisible by 3 and divisible by 5. So num mod 3 equals 0 is just checking any number that is passed in. If we pass it through the moderator operator, which checks for the remainder. If the remainder is 0, that means it's divisible by 3. If the remainder is 5, it's divisible by 5. So pretty straightforward there. And right after that, we're going to put in the conditions that we want to check for if it's divisible by 3 and divisible by 5. So if it's divisible by both, then we'll append the Fizz-Buzz to our answer list. And if it's divisible by 3, then we'll just append Fizz. If it's divisible by 5, then we'll just append 5. So if everyone thinks this is a good enough answer, put a thumbs up. If not, then put a thumbs down. Because this was pretty simple. I feel like you just follow the pseudocode. If it's divisible by 3 or 5, then you append different things. So yes, this is the correct solution and this would work. So during an actual interview, I would step through, oh, actually, sorry, I forgot. There was the else case. So if you're not appending the Fizz-Buzz things, then you should actually be appending the number itself. And here we notice that I wrapped this in a typecast of string. So what this does is it turns the number into the format of a string, because our output array actually wants to only take, it wants to print string values only. And when we're passing it a num, that's of type number. So we want to cast it into a string and they'll append that. So yeah, this is actually the final answer, my bad. So if there's any questions, unmute yourself and speak it out or put it into the Slack chat. And if not, I will continue on. So the result of that is O of n complexity. And when I was in a breakout room, someone asked a great question about, is this the best possible case we can get? So technically, if you think about it, yes, that is the best possible time complexity you can get for this Fizz-Buzz question, because what you need to do is you're given a number n and you have to be able to iterate through each number within that n. So no matter what you do, you're printing n numbers, so your time complexity will be O of n. So this particular solution that I just demonstrated has a space complexity of O of n as well, because we had that answer array, which is of size n, depending on how many numbers you have. And let's think, is there another solution we could use to make things more optimized? So definitely, yeah, like there's solutions that help to optimize for space, because maybe like you don't want to have O of n space, but I'm not going to go into the more optimal solutions, but definitely after when you're finished with a question, think about different data structures or algorithms that you can use to help optimize your solution further. And for this example, perhaps you could use string concatenation or using a hash map to store your values. So that will help save up with some space as well. And actually, no, those two solutions all have the same space and time complexities, but it's just preferable for an interviewer to see those because they know, oh, you're not just going with the brute force solution, you're taking the further step and trying to come up with a separate solution. So yeah, I would then at the end of after I come up with my working solution, I'd really want to step through multiple examples. But since this one is quite straightforward, I feel like if you step through like 3 to 5 examples, that would be good. But I'm just not going to go through all of this because that's a long example, but this is a working solution. And yeah, that concludes our technical interview workshop. So if you have any questions, feel free to unmute or ping them on Slack. And yeah, thank you so much for coming.